All right, so today I'm going to finish up chapter 6, and then that's it. We're done. We're ready for the final exam. Like I said, next week I will just kind of give you guys some more examples, but I do also want to talk about arrays. That's also something important to know, but arrays will not be on your final exam. Okay, so there's two sections to talk about, and yeah, that's it. We know everything we need to know. I do have a review for chapters 5 and 6. So I'll post that up, and then next week we'll kind of just go over it so that you know what you need to study for the final. Okay, so the do statement. Here is the syntax for the do statement. A do statement has the following syntax. You have do, the statement list, and then at the end of it, you'll have the while with the condition that's controlling that loop, and a semicolon, because this is like the end of it. Some students forget about that semicolon that goes there. The statement list is executed once initially, then the condition is evaluated. The statement is executed repeatedly until the condition becomes false. So here is a flow chart of the do loop. So you actually execute the statement, then you check the condition. If it's true, then you execute the statement again, right? And so the difference between the do and the while loop is that the while loop checks the condition before it executes the statement, or the do loop executes the statement at least one time and then it checks the condition. Okay, so that's the difference between the two. You will have to know that. Like those are one of the questions that I'll ask on your final exam. Let's see, an example of the do loop. So here they have a declare an integer called count. They initialize it to 0, and then they increment count, and then they print out what count is, and they're saying while count is less than 5. Wait, what the heck? Does that make sense? Oh yeah, while it's less than 5, then it's going to keep incrementing, and it's going to stop once it becomes equal to 5. Let's see, the body of the loop executes at least once, and then C, reverse number. Let's see, so reverse number, the number of the last digit, and then reverse is equal to 0. Oh, so they're pretty much doing one of your homework problems for you. What the heck? Yeah. So you print an integer out, and then you get the last digit by taking the number divided by 10 of like whatever the remainder is, and then I see what they're doing. They're reversing it, right? And then they're they're taking reverse times 10, and then they're adding the digit. So like if you enter in like, I don't know, 243, right? It's just going to reverse those digits where the 3 is going to be in front, right? And it'd be 342, right? Instead of 243, right? Pretty interesting. Let's run this. This actually looks pretty neat. Right, there's your input, and then they just reverse those digits. All right, and then I tell you what the difference is between the while and the do, which is kind of important to know. All right, so let's see. They ask for an integer, they scan it, and then they just run a do loop, and they have 3 variables, right? They have the number, the last digit, and then the reverse of that number, right? So the number is what you're going to read in from the user. The last digit is going to be what you take off of the number, and then the reverse is going to be. Wait a minute. Oh, so they're actually. Okay, so they're taking that number and they're actually updating it, right? They're dividing it by 10. So on your homework problem, you have to use this approach, what's highlighted, and this approach to what's highlighted to check the number of odd and even in an inputted number. All right, so let's go ahead and take a stab at this. I'm going to name this program reverse number, and I'm going to save it as a Java file. Let me copy this name. I didn't get the R. All right, so we're going to need the scanner class. So import java.util.scanner, and public class, the name of our class, And then our main method, public static void main string array arguments. I'm going to instantiate my scanner object. So scanner scan is equal to new scanner. Read the keyboard. And then you had 3 integers. They had the user input, which is, I guess, they call it number. And then they had the last digit. And then they had the reverse. Okay, the reverse they initialized to 0. And then what they did was prompted the user for a number. And then they said number is equal to scan.next int. And then they did some work right here with a do loop. And they said while, dang, I don't know, what was their condition to stop this? I didn't pay attention to that. Let me hop back over here. While number is greater than 0. So they're going to keep subtracting off the digits off of this number. So at some point it's going to become less than 0. So while the number is still bigger than 0, then you want to keep going into this loop. Okay. So let's see. For now, let's not all just do it all at one time. I'm just gonna we're gonna take like a debug approach to this, and we're just gonna print things out of things that we're going to do. So the first thing I'm gonna do is I'm gonna get the last digit. I'm gonna say the last digit is equal to the number divided by 10, but the remainder of that, right? That's what this means here. And then I'll just say number is now equal to itself divided by 10, right? Divide equals 10. At some point, it's going to get less than, actually, is that true? Not less than 0. Or at some point, it's going to be not greater than 0. Or become 0. Oh, yeah, it's going to become 0 because of integer. So, because when you divide, you can never approach 0. Does everybody agree with that? Like, that's the way math works. But you get closer and closer to 0. But because number is declared as an integer, like once it becomes a fraction, then it's just going to become 0, right? Because Java treats it as just 0. All right, so I'm just going to put that in for now. Compile. Dang it, doesn't compile. What did I do wrong? Right, the one thing I say that a lot of people make this mistake because they kind of get comfortable writing the while without it, because normally when you're at the while, you put like the curly braces, right? But when you're using the do, you need the semicolon right there. All right, compile, run. Oop, zoomed in too much. All right, so to start off, I'm just going to enter 0 as my number, and it didn't do anything. Okay, that's good. And then I'm going to enter in 1 as my number. Okay, and it didn't. Oh, you know what? I'm not printing anything out. What the heck? I'm just doing all this work, and I meant to print out the number. Let me just print out the number. And the last digit. All right, compile, run. I'm gonna enter in a 1. So last digit is 1, number is 0. Let me run this for 0 one more time. Last digit is 0, the number is 0. And let me run it for 123. Oops, I need to run this program. 123. Zoom in. And so it's going through this loop, right? It grabbed the last digit, which is 3, and it said the number is now 12 because it divided off the 10. So it only got that portion of the number. And then 12 is not, is greater than 0. So then it executed the loop one more time, took off the last digit, said the number is 1. 1 is still greater than 0. So it executed the loop one more time. And this time the last digit was 1 and the number became 0. So this is no longer true, right? So then it went ahead and exited the loop. All right, makes sense. I guess I should have maybe put some like new lines on my print so that we can actually see like the separation of how many times this loop was executed. So I'm going to compile this, run it. This time I'll enter 1, 2, 3, 4, 5, 6. I'll press enter, and then you can see all the times that the loop was executed because now it is spaced out, right? So the first time I executed, I got the last digit of 6, and then this is what's the remainder after I took off the 6, right? And then I got the last digit of 5 from this, right? And this is what it was left over. Right, I got the last digit of 4 from this number up here, and this is what was left over. And then from this, right, the last digit was 3, had 12 left over, and then the last digit was 2 here, and 1 was left over. And then since it's just 1, the last digit of 1 is just 1, and the number became 0. And that's when the loop finished. Right, pretty clever, right? You're just using the remainder and then the division. Like, it's the same thing when you're doing chapter 5 homework where you have to count the number of odd and even numbers. It's the exact same thing. Okay, but this time they want you to show like this reverse number. Okay, so to show the reverse number, we're just going to take this last digit and we're just going to add it to are we going to add it? Dang it, what the heck are we going to do with it? We have to times it by 10 every time. Multiply by 10 every time? Yeah. No, because it's 0, right? If it's 0, then it's always going to be 0. You can't add it. Like, everything has to be itself times 10, but not when it's 0. Okay, I got it. So what you have to do is, I was trying not to look because I'm just trying to see how easy it was to figure out in your head, is if you just say the reverse, actually I misspelled that, reverse is going to be equal to itself times 10, right? The first time it's 0, and then plus whatever the number is, right? So if I wanted to plus whatever the number is, then right here I'll just say plus equals whatever the last digit is. Okay, so let me go ahead and print this out as well. So I'll copy this, paste it, and this time I'll get the reverse, and I can see it happening in real time, right? So the first time you come in here, reverse is 0, so 0 times 10 would be 0, and then you're going to add in the last digit, it'll be 1. So the next time you come around, you have to push in another number. You're going to multiply that by 10, so it'll go from 1 to 10, and then you can add in the next digit. Okay. Let me compile, run, and now I'm going to just enter in, let's just go with just 2 numbers. Let's go with 15. Okay, so here the last digit was 5, right? So the reverse of the number is 5, okay? And the number is 1 after we subtracted off the 10, and then the last digit is 1, and because I multiplied it by 10, it became 50, and then I added the last digit, it was like 50 plus 1, became 51, right? And then there's number 0, so that's when the loop stopped. All right, so really what they want you to do is just output this, right? So when this is all said and done, when the loop is finished, then we could just output what our value was. I'm going to go ahead and leave those statements in for just debugging purposes, but right here we can like have our final result, and I'm going to save that, Control S, compile, run, and then we can actually test it with 1, 2, 3, 4. Dang it, wrong spot. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is what we got as a result, right? So this loop is going down that number and just peeling off like 1 digit at a time, and then making the reverse by just multiplying the reverse by 10 and then adding the last digit. Right? Pretty cool, huh? So, and I like programs like that where you actually have to sit down and kind of think, find a way to make this work. All right, so that was a do loop. That example is actually in the book. That was a pretty good example. Pretty interesting. Once again, here are the flow chart for the while and the do. You do need to know the difference between the two. I know it's at least good for one question on your final exam. Yeah, so just as a reminder, the do loop is guaranteed to execute the statement one time, and the while loop doesn't have, like, it might not be executed at all, right? So do loop is one to many times, and while loop is 0 to many times. All right, the for statement. So the for statement is a little weird because you don't really need to have a for statement, to be honest with you. I mean, it's really, you can just use a while or do loop, right, and get the same result. However, it makes it easier to set up iterations, right? Like if you're going to iterate over something over a certain number of times, then this for statement is actually really handy because it kind of puts all the statements that you're going to need like in one spot, right? So just to prove like how easy this is, I'm going to or how much easier it makes what we have to do, I'm going to go ahead and just write a program just using a while loop. So I'm going to come over here and make a new file. And I'll save this as for loop versus while loop. All right, do I need, actually I'm not going to ask the user for data. So public class for loop versus while loop, and then public static void main string array arguments. Okay, so first thing is the while loop. Okay, let me think about this. Let's just say I want to print out like a star pattern 10 times. Yeah, okay. So if I wanted to do that with the while loop, what I'm gonna have to do is say something like this. I'll say like int count is equal to 0 while count is less than 10. All right, then I'll just do system.out.println and then I'll just print out like that star. Okay, and that'll just be like a straight line for now. If you have a loop inside of a loop, then we can make triangles and all kinds of things, and I'll show you how to do that after we learn more about the for loop. All right, so this is just me just printing out a star 10 times. If I were to compile and I were to run and I'm stuck in infinite loop, dang it, because I forgot to increment count. Nobody stopped me, what the heck? You're supposed to be looking out for that. I'm recording this stuff. All right, so I do have to increment count so that this condition does become false at some point, right? So let me recompile, kill, and I said kill, dang it. Okay, recompile. I don't know what's going on. No, it just took some time to kill it, all right. And why is it still?
Did you save and recompile?
I thought I did. Save. Okay, hold on. Did I do something wrong? So count is equal to 0 while count is less than 10. System.println count plus plus. I don't see anything I'm doing wrong. All right, so.
That in the condition though? The while condition? Like the while, isn't that what's called a condition?
If you did a for, you could do that.
Yeah, no, having it down here is okay. So, yeah, let me just Control C. What's going on here? Control C. Stop. It's not working. Control 1. Kill. All right. Let me compile and then run. All right. I don't know what was happening before. It probably just had my same compiled bytecode and was just running it again. Anyway, so that's me printing out 10 stars, okay? Now, to do the same thing with the for loop, puts all the syntax that you need to control a loop like one spot, which makes it more convenient. So the for loop will just look like this. Let's see, I can't use count anymore. I'll just say count 2. Count 2 is equal to 0. And then I'll say while count 2 is less than 10, count 2 plus plus. And then I'll just print out this star. Okay, so it basically takes this initialize that we did here, it took our condition and it took our incrementation and put them all in one spot. Okay, because this is something that is done a lot, especially like when you're iterating through arrays. So the for loop was just basically made for our convenience whenever we needed to do something a specific number of times. Okay, so it's just a central place to put all your statements that control the loop. Okay, it works the same as a while loop. It's guaranteed to run 0 to many times. Okay, it has the same flow chart as the while loop. The only difference is that you can put all the statements in one location. Where the while loop, you had them all like in different spots. Okay. Yeah. All right. So compile, run, and you can see this is what was produced by the for loop, and this was produced by the while loop. Now you could make these a little easier, right? So for this while loop, you could have gotten rid of this count right here, and then you could have put the count right up there, right? You actually could have done the same thing here. You didn't really need to put it there. You could have just put it right here. Now you do need this semicolon, even if you don't have anything like right there, right? Like all the statements above are optional in a for loop for some reason. I don't know why they would want to make it or designed it that way, but they are. But I got the same results if I just did my incrementation here and did my incrementation right here. Okay. All right, let me just Control Z. I was just trying to show you how to increment. All right, so let me hop back to the lecture. Okay, so here's the syntax for the for loop. You have your initializer, you have your condition, then you have the incrementation, and then you have the statement that you're going to output if this condition is true. Okay, now they added all this stuff in here to make it seem like it was different than the for loop, but they're just trying to make it seem, or not the for loop, the while loop, but they're just trying to make it more complex than it actually has to be. I mean, these are all just statements that you would have. If you were to write the while loop with initialization statement and an incrementation, it would have been like the same thing. Right? Does that make sense? Like the same flow chart. But it has like one central location for all these steps. So the way that it works for the for loop is before you even start the for loop, you initialize, you call the initialization statement, which is this first statement in the for loop. Okay. Then you evaluate the condition, which is the second statement in the for loop. This is the condition. So if that's false, then you won't even execute this right here, right? Like you won't even output that statement if that is false initially. And then if this is true, then you execute the statement. And after you've executed the statements, then you'll do the incrementation. So it's going to, after it evaluates this condition, if it's true, it's going to execute all the statements inside. And then it's going to increment, just like the way I designed the while loop. Okay, it's going to keep doing that until this condition becomes false. Any questions on that? All right, the for loop is functionally equivalent to the following while loop structure, and they just basically just did what I just showed you, right? You have the initialization, the condition, the statement, and the incrementation. Let's see, so the for statement, an example of a for statement. Okay, they give you an example. The initialization section can be used to declare a variable. Like a while loop, the condition for a for loop is tested prior to executing the loop body. Therefore, the body of the for loop will execute 0 or more times, right? It's also going to be a test question. So for loop works just like the while loop, 0 or more times, because the condition is evaluated prior to the statement execution. Or in the do loop, right, you actually executed the statement and then evaluated the condition. So the do loop is the only loop where you guarantee to run at least one time. The incrementation section can perform any calculation. So we didn't have to do like add 1. We could have just, subtracted by 5 or multiplied by 5, right? You didn't have to do like plus plus. So what they mean is the incrementation part here, we didn't have to just add 1 to it. If we would have just said, count 2 is going to be equal to itself, let's see, to itself plus 3, I guess. Well, how about we do, if we make it times 2, then we start off at 0. It's going to be an infinite loop. I'm trying to avoid doing this. Times equals 2, right? That's itself times 2, but if you start off at 0, then you'll never break out of that loop because you start off at 0. So if I were to compile and run this, then I'm stuck in an infinite for loop because this incrementation step never actually increases count because you start off at 0 and then 0 times 2 is always going to be 0. Let me kill this really quick. Kill. All right. Did it stop? Yes, it stopped. All right. So if I were to make this actually 1 here and then just said like count 2 is less than or equal to 10, then it's going to increase by factors of 2. So if I were to compile and run, it only executed 4 times, right? If this was like 100, compile, run, it executed, what is that, 8 times? No, 7 times, right? And if I wanted to know what the count was, I could just slap the count in right there, plus equals, and then the star that I print out. Right, so it went from 1, 2, 4, 6, 16, 32, and 64 because of the way that I was increasing that incrementation. Yeah, well, you could have done the same thing with the while loop. I don't know why they didn't tell you that when we studied the while loop. If I wanted to change that value, I could just say count is equal to itself times 2, and the same thing would have happened in this while loop. All right, and then they give you some examples with multiples and stars. Oh, that's cool. I think one of your, so I have to give you guys your chapter 6 homework. And one of the homeworks is to make a multiplication table. So you have to use 2 loops to do that. So it's, pretty fun, I think. You can learn your multiplications and programming at the same time. Kill 2 birds with 1 stone. Yeah. All right, so quick check. Write a code fragment that rolls a die 100 times and counts. Wait, I'm already showing you the answer. Dang it. Write a code fragment that rolls a die 100 times and counts the number of times a 3 comes up. So here they're using a for loop. They roll it 100 times, and if the roll is equal to 3, then they just increment that count and they print out the result. Let's see. So the for loop. Each expression in the header of the for loop is optional. If the initialization is left out, no initialization is performed. If a condition is left out, it is always considered to be true and therefore creates an infinite loop. If the incrementation is left out, no incrementation operation is performed. For each, we're not going to talk about that. We will in Java 2. All right, that's it. Okay, so let me give you an example of nested for loops. So I'm going to come over here and make a new program. I'm going to save this as nested. For examples. All right, so I'm gonna say public class All right, let's see. So the first thing I want to do is like just print out like some type of shape. So if you use a for loop, and we'll just say we'll have int x is equal to 0 while x is less than 10, and then we'll say x plus plus, and then we'll just say system dot out dot print. I'll print out a star. Okay, and that's going to print out the star 10 times on one line, and then I'll just say system.out.println, and this will put a new line. Okay, so compile, run. All right, you can see that I have 10 stars on one line. Now, if I wanted to actually make a shape where the first iteration I only print out one star, the next iteration I only print out I print out 2 stars, and then like and so on, then you can actually have a loop nested inside of a loop, right? Where this here, while x is less than some variable, would be controlled by another variable that's either incrementing or decrementing, right? So if I were to like wrap this in another for loop, say for int y is equal to 0, y is less than 10, y plus plus, open, close on all of this. Okay, so I'm just going to run it like that for now. I'm going to go ahead and save this, compile. As you can see that I made 10 lines with 10 stars on it, right? Okay, now what I want to do is actually like make some type of triangle. Now this isn't very good. Remember I told you guys about this output console here on Notepad++? It doesn't really show doesn't give the true size of an actual character. Like it just kind of, depending on how big that character is, it kind of mushes them all together. So what I'm going to do really quick is I'm going to go to command prompt. I'm going to change directory to Dropbox. Let's see, man, I already forgot. I haven't done this in a while. Public, NVC, Java. Yeah, Java shared content, demos, chapter 5 and 6. All right, and from here I'll say Java C, and this is called for. Wait, what do I call it? Oh, nested for loop. Examples. Okay, yeah. Compile, and then to run, I will just do this, right? And this is the way that it truly looks. Okay, I'm gonna come over here now, and now what I'm gonna do is every time I run this line, I only want to print out the number of x's equal to whatever y currently is plus 1, right? So when y is 0, x would be 1. When y is 2 or 1, x is going to go up to 2. Right? Yeah. So I said that wrong. Okay. So when y is 0, right, x will execute one time, right? This loop will execute one time because x starts at 0 and then it's going to go to 1. When y is 1, this is going to execute twice because x is 0. It's going to go to while it's less than 2, right? So it's going to go to 0 and then 1 and then stop. So now for to compile and to run, you can see I have like this triangle pattern now, right? Where everything is kind of pushed off to the left. And this is the way it looks right here. Compile and run. All right. So let's just say I wanted to like make the triangle to where the point is in the middle. Does anybody know how I would do that? You know, don't you?
Divide by remainder 10.
Divide by remainder 10.
Or just remainder 10.
I don't know if that would work. Okay, so put a space, right? Yeah, but so if x is when x is 0, or at least when y is 0, we would need like 5 spaces, right? And before we actually print out the star, right? But then once it gets to, damn, I don't even know. Wait, I'm trying to think about it in my head. This is so confusing. It wouldn't be 5. It would have to be 10, right? 10 spaces or 9 spaces. Yeah. Is that right? You push everything off. Oh yeah, it is right. So if you only have one character, you want it to be in the middle. Would you use 10? Because you're going 10 high. Yeah. It can be in the middle. Oh wait, it can it? Oh, they need to be odd. You're right. Okay. All right. Well, you know what? How about we just play with this until it looks correct? All right. So this is what I'm thinking. I think you're gonna need like another loop like this, but the loop is going to be the space, right? Now I believe Java is okay with us having x here and x here, because that variable only exists inside of this for, but it's only local to the for loop. But I could be wrong. Some languages get upset when you do something like this. It does compile, so that means Java is okay with us having two x's right now. All right, so what I'm trying to do is whenever x is 0, I need like, what, 10 spaces or something like that? 5 spaces? I have no idea. This is super confusing to me right now. I can't think of how many spaces I need in front of that x. So I think I would need 9, okay? So if y is 0, then I want where I want to go to minus y plus 1. Does that seem right? I don't know. Let's see what it looks like. Y plus 1. All right, I'm going to save that, compile, run. Oh, that almost looks correct. There was no remainder. You said something about a remainder?
Yeah, I was really confident we
What the heck?
Close. I mean, it looks good.
Oh, yeah, I see what you're saying. I switched it. Okay, now I have to do the other side. Okay, I see. So I have to make this go a little bigger, right? To where I have to mirror this side pretty much. So I pushed everything off, right? I have the right amount of spaces, but instead of this being 10, I want this to be 20 stars right here, right? And I want this to be, it's 9, yeah, 18. So I have to multiply x by 2. Does that seem right?
Yeah.
So I want to go to whatever this is times 2. Does everybody agree with that? Yeah, that works, right? Can I see what it looks like here? Oh, but there's 2 right there. Dang it. All right, well, I think it's close enough, right? Yeah, right? You see how I did that math? I just need one more freaking star, but I don't think it's going to work because you can't really go between that. I think you have to kind of get rid of. The thing we got to do is minus a 1 from here. Yeah, so you take whatever y is plus 1 times 2 minus 1, right? Yeah. And then we'll go ahead and throw in that remainder too, just to fuck with people. So we'll just say remainder 2 because 1, no. We'll do remainder 1. I'm just kidding with that. All right, so we'll compile, run. There is 1 star. See what it looks like over here. Yeah, there you go. Dang! What the heck? No wonder I'm teaching this class. You told me to use a remainder.
I'm so fucking confused.
All right, see how easy that is? So in your homework, I'm going to have you make a class that does each portion of the star. I'm just kidding.
You started recording, right?
Oh, yeah, yeah, I'm recording. All right. Yeah, I'm recording, hopefully. Oh, yeah, I am recording. All right, so, yeah, this problem is in your homework, and I do assign it to you, but one of them is actually pretty cool because you're going to make a diamond shape. If anybody has a book, if you look at 6.7, like part D, it's like you're just making that diamond shape where you're going to make the triangle and you make the bottom of the triangle, right? So really all you have to do is just do kind of like what I did, but you're going to need like another for loop where one you're making the top part and then the other for loop you're making the bottom part. Yeah, it would be separate. It would be like me just, I could probably just,
You can show us if you.
I mean, I probably could, but just taking what I did here, right, pasting it, oh dang, what the heck, right? So I'm just gonna run this twice and you'll see what it looks like. This is what it looks like if I run it twice. Okay, but I want to reverse this to be the other way. So if I was going to do that, I think all I have to do is make this a 10 and say while this is greater than, make it a 10. No, because I want it to go to 0 though. Dang, hold on, maybe I make it a 9. I think I want to get, I don't know. We'll try 0 for now. I'm thinking I need to do something like that, but I'm not sure. But then we'll decrement. All right, compile, run. Seems like it almost worked, but by doing that, this is what it looks like over here. So I messed up this is where it started. So I'm off by 1 maybe. So I think you want it to be 9 and you want it to go to 0. I don't know. Let's see. Yeah, there you go. Right, that lines up correctly. Okay. I'm glad you're confused because that means this class is just as difficult as it needs to be.
I feel like life doesn't need difficult.
Yeah. But like, that's what you can use the for loop for. I mean, there's a lot of cool things that you can do with it. And in your chapter 6 homework, you're going to have some programs where you have to like just do stuff like that. All right, are there any questions on anything? All right, so I guess I could give you guys a quiz. You guys want to take a quiz? I kind of don't want to. I want to go home just as much as you guys do. All right, because we're already approaching the end of the semester. Like right now, like if you don't get it, I mean, drop date is like on Friday, right? You like think about it. Like I don't, I just to kind of tell you how I grade. Like I don't give any extra points. So like if your final grade is 68 or a 68, even a 69, like you're gonna get 68 or 69. Like I don't say like, oh, maybe I'll give them a C. It's just your grade is your grade, right? Your curve was throughout the semester when I gave you the opportunity to make corrections on your homework, when I gave you the opportunity to turn in test corrections, like that was your curve, right? So
So 70 is a C?
70 is a C, yeah. So keep that in mind. Yeah, I like to be a little strict because I kind of feel like if you wanted to pass this class, you should have tried from the very beginning, right? And not just be like, oh, I'm so close, I'm 5 points away. Can I do any extra assignments? Like, no, right? So just keep that in mind. Yeah. All right. So with that, I'll go ahead and let you guys go. I will post the chapter 6 homework up before the weekend. It is going to be due. So chapter 5 and chapter 6 homework will be due like in December, right? Like the last week before a final.